Good morning, students. Today we are going to solve all the questions of exercise 10.4. Exercise 10.4 की question में हमसे solve तौरसिका. Question number 1. Find the magnitude of cross product of two vectors A vector and B vector if A vectors is equal to I cap minus j cap plus 7k cap and B vector is equal to 3I cap minus 2j cap plus 2k cap. Hana cross product laurani mathang na kai puthokani magnitude puthokani ko. Question number 1. Here we have two vectors A vector and B vector. Then write all the components of A vector and B vector. Component lo itoe. Find A cross B. Cartesian product of the two vectors in terms of their component. Component means ijk da p taragadi moibani ki Cartesian product sa kaina p which is equal to the expansion of a determinant. Determinant amagi expansion ga mani ko whose elements are first row se always ijk tane. Then elements of second row will be the components of A vector. Write the components of A vector. They are 1, minus 7 and 1. Itoe ko. Then write the components of B vector. Components of B vector are 3, minus 2 and plus 2 sire. Then expanding this determinant by using the determinant law. Determinant law ki expansion ki rule do apply to reko. I cap expanding the determinant along first row. We have first row ka first column ka minus 7 into 2 is equal to minus 14. Formula ki minus sign am legani 7 into minus 2 is equal to minus 14. Minus minus plus and second element j cap here. Find the determinant obtained by deleting first row and second column. We have 1, 7, 3, 2. Then expand this determinant. 1 into 2 is equal to plus 2 minus sign and 7 into 3 is equal to 21. Here third element is k cap. Find the determinant obtained by deleting first row and the third column. 1 into minus 2 is equal to minus 2. Formula ki minus sign ama. Minus 7 into 3 is equal to minus 21. Minus minus plus tareko. Minus 14 plus 14 is 0. I cap 2 minus 21 is minus 19. Minus minus plus. We have 19 j cap. Minus 2 plus 21 is equal to plus 19 k cap. These are the components of A vector cross B vector. A vector cross B vector segi component ngatani ko. Then find the magnitude of A cross B. Magnitude of A cross B is equal to root over x component square plus y component square plus z component square. Here x is equal to 0, y is equal to 19, z is equal to 19. Since 19 square plus 19 square, they have same expression. And their sum will be equal to 2 into 19 square. And square root of 19 square is 19 and square root of 2 is equal to plus 2. This is the magnitude of cross product of any two vectors. Aduna nangi cross product lawase. Cross product of any two vector habase always kay oina phangani vector ram phangni ba duga scalar product lawbadana kay oina phangre. Scalar on phangi ko asida important note sama leire. If A vector cross B vector is equal to C vector. A ga B ga cross product se vector ram phange, then that vector is represented by this C vector. Then this C vector is perpendicular to both A vector and B vector. C gi C se A da su perpendicular hoigani, kana da su perpendicular hoigani C vector da su ka. And therefore a unit vector which is perpendicular to both A vector and B vector is given by nangi any unit vector ama kana da perpendicular hoiba A vector ga B vector ga perpendicular oiba unit vector ama puto hai tarde kaina pirani C cap na p neba, where this C cap is given by C vector divided by magnitude of C, but this C is the cross product of kanagi cross product no A vector and B vector, and magnitude of C vector will be the magnitude of cross product of AB. Then the question do sumai haraba. Find a unit vector which is perpendicular to both A vector and B vector. Hiram taragadi any unit vector perpendicular to AB have a second pigani and to cross product to the magi cross magnitude of cross product to aduna divide togani. It's the important rule later ko the cross product of any two vectors a vector ram phangni adugi vector do given two vectors to the perpendicular. Next question is question number 2. Find a unit vector perpendicular to each of the vector A vector plus B vector and A vector minus B vector, where A vector equals to 3I cap plus 2J cap plus 2K cap and B vector equals to I cap plus 2J minus 2K. Find a unit vector perpendicular to kanada perpendicular oiba a vector plus b gi samda amana a vector minus b gi samda dude koina kana puthokani a plus b puthokani mathangda a minus b puthokani ko. Here we have two vectors and write the components of a vector and b vector. See thoe ko. Find a vector plus b vector. A vector plus b vector is obtained by adding the corresponding components of a vector and b vector. Corresponding component plus 3 plus 1 4, 2 plus 2 4, and 2 minus 2 is equal to 0 k. Then find a vector minus b vector by subtracting the corresponding component. 3 minus 1 is 3 minus 1 2 I cap. 2 minus 2 is equal to 0 j cap. 2 minus plus 2 plus 2 is equal to 4k cap. These are the components of a vector and b vector. Howsik puthoktu se kaino unit vector rama kanada perpendicular oiba a plus b ga a minus b ga the a plus b su vector ramani a minus b su vector ramni ko. And so find the cross product of a vector plus b cross a vector minus b smina vector ani sigi cross product lawrasi a vector plus b cross a vector minus c magi components in 440 amana 204 legre ko I j k. Nasai so high grade expand nangi cross product of any two vectors a expansion of determinant ga mane elements are I j k. Write the components of a plus b 440. Write the components of a minus b 204. Smai ito ko expand re expanding the determinant along first row the expand re I tame first row ga first column ka di 4 16 minus 0 lere ko minus j. First row ga third column ka odd di 4 16 2 into 0 is equal to 0 plus k cap. Sima pase ka eko di 4 into 0 is equal to 0 and 4 into 2 is equal to 8 minus sign am lagani formula ge. And components of their components are 16 I cap minus 16 j cap and minus k cap. And so this vector is represented by this c vector. C vector na represent a na ko. Then we need to find c cap. C cap is given by c vector divided by magnitude of c. Have this the tareba vector se ko na atop vector amna represent a whole c vector haibam na ko. C vector se vector ni unit vector on putho o c vector by magnitude of c 16 I cap minus 16 j cap minus 8 k cap to root over c vector gi magnitude putho aita di root over x component square plus y component square plus z component square. And here x is equal to 16, y is equal to minus 16, z is equal to minus 18. 16 square 256, 256 and 8 square is equal to 64. And their sum is 576. 576 is the square of kanagi square no 24 gi square ni ko. Then write 16 by 24 minus 16 by 24 minus 8 by 24. Dividing denominator and numerator by 8 we have 2 by 3 I cap, 2 by 3 I cap and 1 by 3 I caps minus 8 na loin divide tau thoga nangi components reduce tau ko. This is the vector. This is the required unit vector which is perpendicular to both kanada perpendicular oiba a vector plus b vector and a vector minus kaida b vector. Chumai taroga koina question number 2 se solve tawba ngamai ko. Next question is question number 3. If a unit vector a vector makes an angle pi by 3 with I cap, pi by 4 with j cap and acute angle theta with the k cap, then find theta putho o hareko and hence find the components of a vector. Components of a vector. Step B ribanangi a vector is a unit vector neba. Unit vector oire aduga mana I cap ka make the angle sina pi by 3 ni, j cap ka make the angle sina pi by 4 ni, aduga z axis te ek to se k cap ni ka k cap sina theta haina pireba. Then find the value of theta. Theta gi value se kya no hange ko and write all the components of a vector. Mamang da ina direction cosines and direction ratios ta ko. We have already learned about direction cosines and direction ratios of any vector neba. Dugi direction cosines and direction ratios ki ngasagi definition do ningsingaga khoina apply tawrasiko. Let alpha beta gamma be the angles made by a unit vector a vector with positive x-axis, y-axis and z-axis respectively. in the anti-clockwise direction. In xyz highway maramdi kaigino, I cap is acting along x-axis, j cap is acting along y-axis, and k cap is acting along z-axis. And they are mutually perpendicular unit vectors ngatane. Aduna I ga a ga gi marakta lebisina alpha. A vector siga j ga gi marakta lebisina beta ko. A vector ga z ga gi marakta lebisina gamma tare, and they are measured in anti-clockwise direction. Clockwise the log ya deko kai the logan equina anti-clockwise direction the logan. Here we have alpha is equal to pi by 3, beta is equal to pi by 4, and gamma is equal to theta. Nanga z axis ka make to bose mana theta ne pire, and theta should be acute angle. Acute angle means angle lies in 0 to 190. 0 dagina 90 bhogi marakta leba angle oigadaba. Since alpha beta gamma sina direction angle soiba maramna cos alpha cos beta cos gamma se direction cosines ka wiko. Direction cosines oitardi formula am laigi bane. Karamba formula laigi cos square alpha plus cos square beta plus cos square gamma will be equal to 1. Se nangi direction cosines ki property niko. Here cos square, then replace this alpha by pi by 3 and beta by pi by 4, and we have cos square gamma equals to 1. Si thamme ko. Cos pi by 3 means 60 ne. Cos 60 is 1 by 2 right whole square, and cos 45 is 1 by root 2, then right whole square plus cos square gamma is equal to 1. Gamma ki value se hojik phangde ko. Then right cos square gamma 1 transpose 1 by 2 whole square is minus 1 by 4. 1 by 2 root whole square will be equal to minus 1 by 2. Root 2 the square log taradi 1 by 2 in phange ko. LCM lore. LCM low se 4 tare. Into 4 minus 1 minus 2, 1 by 4 phange. Taking square root on both sides, value of cos gamma is equal to plus minus 1 by root 2. Plus tabaswe minus tabaswe, but theta se acute angle ni na pirabanina, this cos theta will be equal to 1 by root 2. Koi na gamma gi mahuta theta the sense the record 1 by root 2 lore dudi theta na 1 by root tabase karamba angle the tai haita di 45 the tai ko. Possible values of theta is pi divided by 4. Pi by 4 means radian niko, aduga degree do olaga di 45 ore. And therefore the components of a vector is given by kaigi formula na p. A vector is equal to cos alpha I k plus cos beta j k plus cos gamma k k neba. Dudi si cos alpha. Alpha se ina pi by 3 center di 1 by 2 I k tare ko. Cos beta की value di 1 by root 2 j kf, and cos gamma की value so kya tarani 1 by root 2 k kf, and these are the components of the a vector, and value of theta is equal to pi by 4. Sina kari rule sijenaraga solve tore direction cosines ki rule paale ko. Your next question is question number 5. Find lambda and mu if 2ik plus 6jk plus 27kk cross product ik plus lambda jk plus mu kk is equal to 0 vector. Find lambda and mu if the cross product of these two vectors is equal to kya taradi 0 vector or nangi piriba vector sanisigi cross product sina 0 taragadi find the value of mu and lambda haibako. And ito the cross product of these two vectors is equal to 0 vector. 0 vector ne pireko, and cross product of these two vectors is equal to expansion of a determinant ijk to 627 1 lambda and mu equals to 0 vector. Expand to se expanding along first row. First row the expand to reco I cap 6 into mu minus 27 into lambda minus j cap 2 into mu minus 27 into 1 plus k cap 2 lambda minus 6 into 1 is equal to 6 is equal to 0 vector. 0 vector means 0 vector is a vector whose components are all equal to 0. My components in se kai taba 0 loin taba ko. Dudi sina x component, sina y component, sina z component neba. The first ki se kona cancel to raga second ga third ka se laure ko. Equating the corresponding component, we have 2 mu minus 27 is equal to 0, and the 2 lambda minus 6 is equal to 0. From equation number 1, mu of lambda is equal to 27 by 2, And from equation number 2, we have lambda is equal to 3. And therefore, mu is 27/2. Possible values of mu and lambda pire ko asumai taraga. And equation number 5 says solve tore. Next question is question number 6. Given that a vector dot b vector equals to 0 and a vector cross b vector is equal to 0 vector, what can you conclude about the vectors a vector and b vector? Nangon the vectors ani pire a vector and b vector haibam pire ko. Since a vector dot b equals to 0 and a vector cross b vector is equal to 0 vector, then a b gi maram that nang kari haibam ngamge and hangin question se ko. For question number kya gi 6 ki. If a vector dot b vector equals to 0, then either kai fangisida a vector 0 vector oiba or b vector 0 oiba or a vector is perpendicular to b vector. If a vector is perpendicular to b vector, then theta se 90 chale ko adude a dot b ki value se 0 tane basida cos use tawe ko. If a vector cross b vector is equal to 0 vector, Cartesian product magi cross product of two vectors is the 0 vector tataragadi, then either a vector equals to 0 or b vector equals to 0 or a vector is parallel to b vector. A dot tana cos oina sizinaba ko aduga cross product tana sin sizinaba. Sin 0 chatpa haibase a ga b ga parallel oirakana chatleba di theta sina 0 taba natraga theta sina pi tarakana chatliko. Duna segi case ahan bagi case sida a se 0 chatpa or b se 0 chatpa or a se perpendicular to b tare. Second case dina a se 0 taba or b se 0 taba or a vector is parallel to kanada parallel tare b vector tare ko. But a vector and b vector cannot be parallel and perpendicular at the same time. Chap manaba vector ani se matam amata the parallel ga perpendicular plug oisin be adeba. Duna sigi case se khuna neglect orani ko. Neglect oradi karamba part khatang lem howe. Here we have either a vector equals to 0 or b vector equals to 0. Nangi possible or biaba case marise. Sigi manung the oibiari se a vector se 0 taba or b vector se kai taba 0 oiba. Sida gena later ko. Parallel ga perpendicular dugati ani makse plug oisin be adaba maram na koina sigi case neglect orani. Next question is let the vectors a vector and c vector be given is component from the loin pithoeka. Then show that a vector cross b vector plus c vector is equal to a vector cross b vector plus a vector cross c vector and pire. Now on the vectors ahum pire a vector b vector and c vectors are given in terms of their component. Then show that distributive law niko. A vector cross sum of b vector and c vector is equal to sum of a vector cross b and the a vector cross c have distributive law se koina component form the proof tawada. Question number 5, question number 7. Here we have three vectors, a vector, b vector and c vector. Components of A are A1, A2, A3. Components of B are B1, B2, B3. Components of C are C1, C2 and C3. So my pire ko. First nang nakai puthokani B plus C ki expression se darkar oiba kya si putho. Find the sum of BC. BC is obtained by adding the corresponding component. B1 plus C1 I cap, B2 plus C2 J cap, B3 plus C3 K cap. Here left hand side cha ina right hand side ka mane no uttoini ko. Left hand side ki expression che kaino haradi a vector cross b vector plus c ne. A vector cross b plus c is equal to expansion of a determinant whose elements are I, J, K. First write the components of A, A1, A2, A3. Then write the components of B1 plus B plus C. B plus C की components से B1 plus C1, B2 plus C2, B3 plus C3 सितारे. Then expanding this determinant along first row. We have I cap. First row ga first column ga kao. Ani se kakpa matamda A2 B3 plus A2 C3 si phange ko minus A3 into B2 minus A3C2 minus. In the first term. Second term minus J cap. Find the determinant obtained by deleting first row and second column. A1, A3, B1 plus C1, B3 plus C3. See determinant tareko. By expanding this determinant, we have A1 into B1, A1, B3 plus A1, C3 minus A3 into B1, A3 into C1 minus some laser neko plus K cap. First row ka third ka kaksiko. Do the A1, A2, B1 plus C1, B2 plus C2. By expanding this determinant, we have A1, B3, K cap, A1, B2, A1, B2, and A1, C2. 2 oigadamniko, 3 oibyade, and A2, B1 minus A2 and C1. Jumai ito eh. Ito nga tani. Then find A vector cross B. A ga B ga na cross law siko. I cap plus J cap K cap. Dudi A component A1, A2, A3. B gi component B1, B2 and B3. Expand to C expression che phange ko. Then find A vector cross C. I, J, K. First write the components of A, A1, A2, A3. Write the components of C, C1, C2 and C3. Expand to asai gi rule do. Na first row, first column ka A, first row, second column ka A, first row, third ka A ko. Then right hand side. Expression of right hand side is A vector cross B vector plus A vector cross C vector. To the I, J, J, K plus to siko. I plus to bukanda A2 B3 minus A3 B2 plus. Kailakani A2 C3 minus A3 and C2. Sifange ko. Second term minus J cap. A1 B3 minus A3 and B1. Simalajare. Matangda plus A1 C3 minus A3 and C1 minus common law gi vaine ko na minus minus plus lai se ko. Plus last term gi K cap. A1 B2 minus B1 A2 lejare ko. Sigi K cap ki component se. A1 plus C2 minus A2 and C1. Sigi expression chiga mamangi A vector cross B plus Sigi expression chiga. Ani se chamana neba. Ani se chamana ba maram na ko. Therefore, A vector cross B vector plus C is equal to A vector cross B plus A vector cross C. Sumain tare ko. Sigi law se kai kawe. Distributive law kawe. Here last question. Last question is question number 9. Find the area of the triangle with vertices A. Components say 1, 1, 2 qua. Coordinates say 1, 1, 2 pire. Then point B coordinates are 2, 3, 5. And the point C coordinates are 1, 5, 5. Now on the triangle pire. There is a triangle ABC. Component magi vertex niko ABC sina. Man hai se kaino. Find the area of the triangle ABC. ABC area of the triangle putho hai na observation of cross product of two vectors the area of parallelogram area of triangle ki concept ta ko area of triangle hai tar dekho na side ani ki length se lobam change in terms of vector de express ta gadaba ko na first find BC vector and atopa mana kai putho ani BA vector se putho BC vector position vector of C terminal minus position vector of B initial C component form the is equal 1I cap plus 5J cap plus 5K cap minus components of B 2I cap plus 3J cap plus 5K cap nangi coordinates sing the first I na second J na last K na sumain subtract down 1 minus 2 is equal to minus 1I cap 5 minus 3 is equal to plus 2J cap and the 5 minus 5 is equal to 0K cap. B a vector is equal to 0 A vector minus 0 B vector. May reco which is equal to nang component from the area subtract down later. Now find the cross product of B vector BC and the BA vector. Nangi sigi hek thang na side anisa sigi Cartesian product law. IJK, write the components of BC minus 1, 2, 0. Components of BA minus 1, minus 2, and minus 3 ito equal. By expanding this determinant, we have minus 6I cap, minus 3J cap, plus 4K cap. Join ire. Then find the magnitude of B vector cross BA. Magnitude law root over 36 plus 9 plus 16 is equal to root over 61 tareko. Since the area of the triangle ABC is equal to half magnitude of cross product of any two sides. Nangi side ahum zes dagi nang na longning ba side ani law. Aina hojik BC ga BA ga lawreko. Nang na AC ga AB ga harasu ai CA ga CB ga harasu nang na longning ba side ani lawro. Cross product lawro magnitude lawro 2 na divide taw taraga di kay fange area of the triangle ABC phanganeba. Therefore area of the triangle ABC is equal to half magnitude of BC into BA cross product tareko 1 by 2 root over 61 square unit. Find taraga koina area of the triangle se putok pangam. For today, let's end here.